this is the theta, and this is kept inside the bracket also. So theta is equal to argument of this. But see here what here theta is found in which direction? Smaller angle theta is found in the direction of clockwise direction. So in the clockwise direction, you will have to take negative sign, because it is negative angle. All the angles which are found in the clockwise direction are called negative angles. So here you will just cancel out. It is this, so minus pi by 4. So minus pi by 4. So argument here, argument of this complex number z is equal to theta, and then it is minus pi by 4. Here you will find out theta 45 degree, but as argument is minus theta, here minus theta. So now the polar form of this complex number z is equal to r plus cos theta plus I sin theta. Okay, so now r is equal to what? So r is equal to root 2. We have calculated from 1, and this from 2 argument is equal to this. So from 2 argument, in place of argument we will put the square bracket, and in place of argument minus pi by 4, and then plus I sin minus pi by 4. So a smaller one you will have to take. So this is the polar form of the complex number. So we will have to be very careful about it, that which will be the smallest one, whether it is negative or positive angle, but you will have to take the minimum value. Those value will be minimum, but also take care that sign of the angle, because the angle may be positive or negative, as it depends upon that the complex number lies in which quadrant. Okay, so if the complex number lies in different quadrants, so its arguments and its formula is also given in the NCERT book. If you will go through the NCERT book, how to find it, all the formulas are given, and I have also explained in the previous video that how to find the argument of the different type of complex number which lies in the different quadrant in 4 cases. So 3 I have done, 3 or 4 I have explained all these things. So please see in my playlist. I will give the link of the playlist also, and previous I have made videos, 7 videos on complex number, or more than 7 videos I think. So please go through it, and you will just see how to find the argument, and I will explain in detail. So now I am coming to the next question. So now here next question is question number 4. Here we have to convert it in the polar form. So let us suppose this is z is equal to minus 1 plus I, and this is in the form of x plus iy, or therefore if we will equate real part, so x is equal to minus 1 and y is equal to 1, because iy is equal to I, so I will cancel, you will get y is equal to 1. So it is in the form of ordered pair minus 1 1. So it means that this complex number lies in which quadrant? In second quadrant, because the second x is negative and y is positive. So I am just drawing a figure. So minus 1 and here is 1. So origin is this, and real axis, and this is the imaginary axis. Imaginary axis means here all points are except origin, because 0 is a real complex number. All points represent imaginary number or purely imaginary complex number. So now if we will come to here, you see that suppose that we will get the point A. So it is minus 1 1. So minus 1 1 represent which complex number? whose real part is -1 and imaginary part is 1i. So this is -1 plus I. So this is the question, and suppose if we will join over here, so this is the value of R. This distance we have to find. This distance will be the modulus of the complex number, and here this is the angle, the smallest angle, and if we will go in this way, so this will be the bigger angle. So we will take the smaller one as argument of the complex number. So suppose this angle is equal to theta. Okay, so now first of all we will find R. So R is equal to mod Z, and it is equal to root under x square plus y square. So root under -1 square, we have calculated equated the value of x and y. So this is root under 1. It is 1 plus 1, so root under 2. So R is equal to this. So this distance is root 2, and now we have to find the angle which is formed in anti-clockwise direction, means it is positive angle. So we will take here, because the numerical value of this angle is least, that is why we will take this. So argument of the complex number we will find by 180 degree minus theta, and theta, how we will find? Tan theta is equal to mod y by x. So modulus y is equal to 1 and x is equal to -1, so again it is coming 1. So tan 45 degree is 1, so theta is equal to 45 degree. Therefore argument will be, argument of z is equal to 180 degree minus 45 degree, so it is 135 degree, and then it is multiplied by 180 degree to convert it in radians of 45 into 3, and it is 4, so it is 3 pi by 4 radian. So this is the argument of the complex number. So this is taken as, suppose, equation number 1, and this is taken as equation number 2. Therefore, just a minute. Therefore polar form of this complex number -1 plus R can be written as R under bracket cos theta plus I sin theta. So in place of R we are writing root 2 and cos 3 pi by 4. Theta is argument, and now here you don't see that this theta is argument. Theta is 180 degree minus 45 degree, so it is 3 pi by 4. So this is the answer of this question. So I think there will be no problem at all. If you are having a problem, you just comment over it. So now we are coming to next question. Next question is question number 5, and let us suppose z is equal to -1 minus I, and it is in the form of a plus iy. So x plus iy, so x is equal to -1 and y is equal to also -1 will come if you will equate it, or you can just equate iy is equal to minus I. So I will cancel, so I is equal to -1. It means that the complex this complex number in the ordered pair form -1, so it means that it lies in which quadrant? Lies in third quadrant. So we have to find out. So suppose if we will draw a Hagen diagram over here, y o y dash and x o x dash. So suppose this is -1 and here is this -1 I. So we will get a point, suppose P, whose coordinate is -1, representing the complex number -1 I. If we will join over here, we will get R. Okay, this is the modulus, and see here this angle this angle will give the argument if we, or this angle. So see which angle is the smallest. The smallest angle is this, so we will have to find the smallest one. So now modulus of z, r is equal to root under x square plus y square. So root under x is minus 1 square and y is 1 square, so it is equal to root 2. And now tan theta you will find out. Tan theta is equal to modulus of y by x. This is the rule. So it is minus 1 divided by minus 1. So it is equal to minus cancels 1. So tan 45 degree and 45 degree. So tan 45 degree, you know, it is tan theta is equal to tan 45 degree. So theta is equal to 45 degree. Now this value is taken as the argument. So argument, you have to find argument of z is equal to 180 degree minus 45 degrees. So it is equal to 135 degree again, but it is forming in which direction? In clockwise direction, because in clockwise direction it is forming. Therefore we have to take negative sign. We have to put negative sign, and then we multiplying by 5 by 180. So 45 3 times, and it is 4 times. So minus 3 pi by 4. So this is coming the argument. So now the polar form will be here. I am writing this. I am not writing question number 6. I will do in the next space. So see here. So question number now here. Polar form of complex number minus 1 minus I is equal to r cos theta plus I sin theta. So if you are having the command, then no need to draw the diagram, only to explain that I have done it. So r is equal to root 2. From here we have equation number 1. So from 1, and this is 2 argument, and from 1 and 2 we will put the value. So this is root 2, and then I am writing over here a small square bracket. I am taking cos, and this is minus 3 pi by 4, and then plus I minus 3 pi by 4. Okay, so this is the answer. This is in the polar form. So hope you will understand. I am not going to find this angle because we have to take the least one. So next I am coming to the next question number 6. See, in question number 6 it is given only minus 3. So let us suppose z is equal to minus 3 and it is equal to x plus I by. It is purely real complex number, so x is equal to minus 3 and I by term is equal to nothing, so 0. So y is equal to 0. So therefore this complex number will be in the ordered pair form. So minus 3 1. So it lies in purely real axis, x dash axis. So this is the complex number. So where it is, it will lie. See, just a minute. So now see, suppose this is minus 1, minus 2, and then minus 3. So minus 3 comma 0. So this is the complex number. Okay. So now y o y dash and x o x dash. So now here this is the complex number which represent minus 3 plus 0 I. Minus 3 plus 0 I. So this makes how many angles with the positive direction of x-axis? 180 degree. Quite obvious. So if we will from the figure, it is directly we can write that the argument of this complex number z is equal to theta is equal to 180 degree, as you know that it is pi radian. Directly I am writing, otherwise it will unnecessarily it will take time. And now the r is equal to root under x square plus y square and x square minus 3 whole square, and it is 0 square, so it is equal to 9. So you will have to take always positive, because from here to here this r, this sign r in the negative direction, but we have to take the modulus is always positive. So 3. So therefore polar form will be polar form of minus 3 is equal to r under bracket cos theta plus I sin theta, this. So now I am writing over here. So in place of r we will write just a minute 3 and then cos I plus I sin here cos, here I am writing in the polar form is equal to r and bracket cos theta plus I sin theta. So theta is second argument over here, so it is pi, because argument is theta and theta is pi. So as you know that cos pi is equal to minus 1 and sin pi is equal to 0. So if you substitute, you will get it minus 3. So this is the answer. Now we are coming to question number 7. Now question number 7. Just a minute, I will see. Question number 3 plus I. So here it is root 3 plus I, and here we have to convert this complex number in polar form. So let us suppose z is equal to root under 3 plus I. So we have to convert in polar form. So you just see x plus iy. So x is equal to root 3 and y is equal to 1, iy is equal to I, so it will be 1. So order pair will be root 3 1 comma 1. So it lies in which quadrant? Lies in first quadrant. So in first quadrant argument is always acute angle. So now first of all r is equal to root under x square plus y square. So now root under root 3 square plus 1 square, so it is equal to 3 and then 1 4, so it is 4 and then it is 2. So therefore r is equal to 2. This is the modulus of the complex number, and that modulus represent the distance of the complex number from the origin. Now argument of z we have to find. So as we will have to find out this, so tan theta is equal to modulus of y by x. So modulus of y by x 1 by root 3. So 1 by root 3 modulus is 1 by root 3. This is equal to tan 30 degree. So theta is equal to 30 degree. So here 30 degree into pi by 180. So directly you can write also pi by 6 radian. So here from here we can write theta is equal to theta, and theta is equal to pi by 6, and pi by 6 is the argument of the complex number. Therefore the polar form of this complex number root 3 plus I, it is equal to r and a bracket cos theta plus I sin theta. So r in place of r substitute here r is equal to, here we have calculated r is equal to 2, and theta is argument is equal to pi by 6. Pi by 6 is the argument. This is second. So using 1 and 2, we get r is equal to 2 cos pi by 6 plus I sine pi by 6. We can find out. So this is the polar form. So hope you will understand it. So we don't have any problem, I think. And now in question number 8, we will have to find out the polar form. Question number 8. Question number 8 says convert I into polar form. Okay, polar form. So this is the question. So I will see here. Solution. So let us suppose it is z is equal to I, and you will equate with x plus iy. So real part is 0, as you know that I in I, and iy is equal to I. So it is equal to y is equal to 1. So this complex number in ordered form, it is 0, 1. So it means that if we will draw the figure, so 0, x is equal to 0, so it is origin, and then x-axis here, and then it is y-axis in the origin plane. So 1, suppose that here is 1. So and this point is A. Its coordinate is what? X coordinate is 0 and y coordinate is 1. So it represents 0 plus equal to, this is equal to 0 plus 1i. So it is equal to I. So now here, how many angle in the anti-clockwise direction it makes? It is 90 degree. So 90 degree, as you know that 90 degree is equal to pi by 2 radian. So argument is equal to argument of this complex number, argument of I is equal to pi by 2, and now we have to find it's the distance r. So this distance r is equal to what? So it is clearly 1. Clearly the modulus of this complex number will be 1. If you will find out with the formula, you will get the same. So therefore the polar form is equal to r under bracket cos theta plus I sine theta. So